The great thing about adding polynomials is it's literally just combining like terms, which you have done before. So if they're the same, right? I put all my apples in one basket, all my oranges in one basket. Well, take a look here. I've got 3x squared plus 7x plus 5x squared. Well, there's two things that look alike, right? X squared and x squared. Those are my apples. X will be my oranges. You cannot mix those two things, but I can mix the x squared and the x squared. So I'm going to say 3x, I'm going to combine like terms, I'm going to say 3x squared plus 5x squared gives me what? 8x squared. And there's nothing to go with our 7x, so it just stays by itself. And there you go. You have simplified or added that polynomial. Easy peasy lemon parcheesi. Now, subtracting is a little different, but we're going to end up doing the same thing. We're going to end up combining like terms, but first, we have to take care of the subtraction, that little negative symbol there. Well, remember, when something's right in front of a set of parentheses like that, we do what? It starts with a D. Distribute. So you're going to take it and you're going to distribute it here. Well, when you do negative 1 times anything, it's just going to make it a negative. So, all right, negative 4x squared. Negative 1 times positive 7x. Well, now it's going to be negative 7x. Negative 1 times negative 6. Remember, a negative times a negative is a positive. So now it's plus 6. But I can't forget about this 6x over here. It's still here. Now remember, I can't put an x and an x squared together, but I can put an x and an x together. What would be negative 7 and positive 6x together? Negative 1x. There you go. You took care of those. There's nothing to combine with that negative 4x squared, so I'm going to just bring it down. There's nothing to combine with our constant, so I'm going to just bring it down. And there you go. You have your simplified polynomial, your subtracted polynomial. There you go. That's it. All right, let's look at that next one. Let's look at example 1 and example 2. You're going to look at example 3 on your own, okay? And we'll talk about that in just a second, but let's look at example 1 and example 2. This looks really long and complicated, right? Because there's a lot of letters, there's a lot of numbers, but you need to get your apples in the same spot, you can get your oranges in the same spot, and now we're going to throw in one more fruit, but that's okay. So take a look. I have x squared, x squared. Are there any other x squared? No. So I know that these two yellow right here, because they have the same variable with the same degree, they're going to go together. Let's keep looking. Here's xy. Here's xy. Are there any other xy's? There's not. So I know that these blue ones are going to go together. Let's take a look at another one. We have z and we have z. So I know these z's are going to go together, right? So let's start with our yellows. Negative 4x squared plus 7x squared. Well, what's 7 minus 4? 3. X squared. There we go. We took care of those. Let's look at our blue ones now. Positive 8x. Positive 8xy, and negative 12xy. Well, negative 12 and positive 8 together give me negative 4. So negative 4xy. And there you go. You took care of those blue ones. Now, even though this is outside of the parentheses, the great thing is, because we're adding, you're still just combining them. So 6z plus 3z, well, what's 6 plus 3? 9z. Can I simplify any further? Is there anything else to combine here? There's not. So that's it. That's your final answer. All right, let's take a look at example 2. It says write an equivalent expression, right? So now we're going to subtract these polynomials. Well, if you'll remember from what we did up here, I'm going to take this subtraction, this negative, and I'm going to distribute it into this parentheses. So now, instead of it being positive 3/4, it's going to be negative fourths x. And instead of negative 2x squared, it's now going to be positive 2x squared, because we know that if I do a negative times a negative, it's going to be positive. And this all comes down as it was. Here's our constant, 1/3, 1/2 x, nothing changes on this side, minus 3x squared. Well, we can do it now kind of like how we did on example 1. I know that the constant is, going to combine with the other constant. Are there any other constants? Are there any other numbers here that do not have a variable attached to them? No, so I know that's going to stay there. Okay, then let's go look. I've got x and I've got x. Well, so I know these two are going to go together. Okay, and I'm sorry, this should say x squared. Then I have x squared, x squared and x squared, so I know these two are going to go together. But remember, here's what's tricky. We have to make sure that it ends up with the leading coefficient, the x to the second degree, the variable, and then the constant term. Make sure you stay in that order. So first, could you put together the two x squareds? Absolutely. So negative 3x squared and positive 2x squared leaves me with negative x squared. So there's our leading coefficient, and you're done with this. Now we can put together our variables, right? Our 1/2 x and our negative 3/4 x. Now, some of us maybe remember how we subtract fractions. It's been a minute, okay? But basically, you just need to make sure that the denominators are the same. What can I multiply by 2 to get a denominator of 4? 2. Now, I know that 2 times 2 is 4. Now, whatever you do to the bottom, you have to do the top. So 1 times 2 is 2. And now, you can do 2/4 minus 3/4. Well, 2 minus 3 is negative 1. Don't forget that variable, though. Negative 1/4 x. And there you go. You took care of your two blues. Now, remember, is there anything I can combine that with? There's not. So it's just positive 1/3, and there you go. You've simplified it as far as it would go. This is its equivalent expression. Okay. Let's move on to the back, and we're going to look at multiplying. Oh, really quick, you are going to work on example 3 on your own. Remember, on a rectangle, you know that this side and this side are equivalent. You know that this side and this side are equivalent. So if this left side is negative 3x plus 20, this has to be negative 3x plus 20. If you know that top is 4x squared plus 7x, you know the bottom has to be 4x squared plus 7x. And if I'm looking for the perimeter, what am I doing with all of these sides? Adding them all together. All right, so you're going to try example 3 on your own. All right, let's look at the back though. Multiplying polynomials. So this is a little bit different. There's two different methods that we can use. The first method is the FOIL method. FOIL just means you're distributing each part inside. So even though there's 3 different parts here, you're going to take all of them and distribute it to both of these. So let's try it here. We're going to say, all right, we're going to take this first, this leading coefficient, and we're going to take it and we're going to multiply it to this first one here. Well, x squared times 3x. Here's where it's a little different too. If there's not a number in front of the variable, what can we assume is there? A 1. Well, 1 times 3 is 3. What happens when we do x squared times x? Even though we're multiplying, because it's a variable, they add together. So x squared plus x is x to the third. Okay? Now you're going to take it and you got to do it to both parts. So I'm going to take that x squared and distribute it to that negative 5. Well, we know 1 times negative 5 is negative 5, and then x squared times nothing is just going to be x squared, right? Not nothing, but 1. So it's going to stay just like that. Now, you took that first part and you distributed it to both of these, so you're done with that one. We can move on to the next one. So now I'm going to take 4x. I'm going to do the same thing. I'm going to distribute it here. Well, 4 times 3 is 12. And x times x is going to be x squared. So there's 2 x's. Now I'm going to take that 4x and distribute it here because you have to do both parts. Negative 5 times 4 is negative 20. X times 1 is just x. And I can already tell I'm about to run out of room, but we're going to keep going. So you're done with that one. You distribute it to both parts. Now you can do that last one, that constant. So I'm going to take that 7. I'm going to multiply it here. 7 times 3 is 21, but I can't forget that x. 21x. Okay? Now I have to do both parts. So 7 times negative 5 is negative 35. And now that you have done the entire FOIL method, you distributed it to each part, all you have to do is combine like terms. So if I'm looking here, this first one, are there any other x to the thirds? There's not. So we're going to say 3x to the third. Okay? Now, there are negative 5x squared and an x squared here. Well, positive 12 minus 5x squared, what's 12 minus 5? 7. So plus 7x squared, and you got rid of both of these. You combine them. Now, negative 20x and positive 21x leaves me with 1x, or just x. And are there any other constants? There's not, so it just comes down as is, and there you go. That is your final expression. I know it's long, but is there anything else left to combine? There's not. That's it. Okay, now, if you didn't like the FOIL method, there's also the box method. For the box method, we take everything on that left side, right? So we put it on the left side of our box. We give x squared its own box, we give 4x its own box, and then we give 7 its own box. Then we go over to our other side and we give them each their own box at the top. So 3x gets its own box and negative 5 gets its own box. Okay? And then you multiply inside. So kind of like how we did on that other side, but here we go. So we say x squared and 3x multiplied together, multiply these two things, it's going to end up in this box. That leaves me with 3x to the third. Okay? Then you do it here. We got to make sure we do it here too. Well, negative 5 times x squared is negative 5x squared. Same thing here. 3 times 4 is 12x squared. Negative 5 times 4x is negative 20x. 3x times 7 is 21x. Negative 5 times 7 is negative 35. So this one, it kind of just depends on what you like better. If you want to set up a box and do the box method, it's the same thing. You'll get everything you need, and then you just combine like terms like we did here. If you want to do the FOIL method, where you just kind of do your over like that, that's wonderful. It's completely up to whatever you think is the easiest for you. What you're going to remember when it comes to that STAR test. Oh, what did Miss Bailey say about that FOIL? Distribute something. Maybe that's confusing. So maybe you say, oh, I know, I'll do the box method. And you create something like this. Either way is completely fine. Find what works best for you. You're going to do this last one on your own. You are going to either use the foil method or the box method, and you're going to figure out which one of these is the answer to this multiplying polynomials here.